Says you're live. So, good evening, YouTube. Okay. And it says I'm live on Twitch as well. So, good evening, Twitch. What's up? Up, chat. Okay. Chat. Okie dokie. Type something in chat so that I am aware that I'm talking to whoever. Let me let's pull the chat on the other monitor. Pop out the chat. There we go. Okay, Twitch is next. Twitch.tv / Linux Renaissance. Pop the chat out. Very nice. XGUI4, welcome in. Nice played, welcome in. Grabbing a drink, that's good. Fluid is useful. Okay, here we go. We have 4 people already. Only 2 minutes in. Very nice. We're probably going to start very soon. But still, some people should join first. Let me see if I can... let me switch to another screen to remember once again what was the IP address. SSH 235. Yes sir, 235. Okay, this goes to the left, this goes to the right. Very nice. Someday I'm gonna make the chat make some more sense. I really am not sure what exactly I want to do. Oh well. I could. Is old C better than modern C? First of all, we are not switching to old C. It's just that the book called Modern C wasn't very good in explaining how things work. It wasn't bad, but the storytelling of that book was not ideal for this channel and for this group of people working together, at least not with me in charge. So is the old C better than new C or vice versa? I don't know. I think it's all the same. It's just that some new additions are like more convenient, you know. I don't know everything. Actually, I know very little, but from what I read in the book so far, it's like you don't need this include in C23 if you want to use this functionality. You can make you can simplify some of the lines, some of the syntax, you know, stuff like that. So how much better is it? I don't know. Apparently C11 and C17 are pretty much the same thing, while C23 is quite an addition to the standard. And as you said in the matrix chat, XGUI4, It's kind of still being worked on. I mean, the standard has been finished for the past 2 years. That's a fact. And GNU C compiler collection, that one employs pretty much the entirety of the standard, with almost nothing being left out, at least nothing of importance. While LLVM, the Clang compiler, that one is kind of still catching up. But at the same time, the Clang version 23 is quite a bit good. It's coming out this year, and as I understood it, it's quite well caught up with the standard. So you can use that one as well. And it's not really a moving target. I mean, it was never a moving target, mind you, as you said in the Matrix chat. It was never a moving target after the year 2024. After the year 2024, it stopped being a moving target. The only thing that's moving is the development of LLVM. But that's up to Apple to finance the completion of that. Okay, 5 people here. This, so it's not like Rust being moved. Rust is really quite a lot different. I mean, Rust is completely, not completely, but constantly changing, you know. Whatever is being changed in C is being changed in the span of 5+ years. And even when they do change something, it's always backwards compatible. So you can always use the latest compiler and be sure that it is going to be able to compile the code that was written in the older ISO standard, contrary to Rust, which changes, I don't know, every couple of weeks, basically. So you really need to stick to one version of Rust if you want your stuff not to fall apart. Etherweb, welcome in. C99 is the single best upgrade to the standard. Some swear by C89 for maximum portability, but C99 is close and adds a lot of great stuff like these designated initializers, which even Zig and but Zig is they're catching up quickly. When it comes to versioning and the moving targets thing, Zig still is a very large moving target, and especially the Zig author has already said so. With these are his own words. Like, he is not afraid to innovate in order to really make it a good product. So if something breaks, it will break. But once he is like 100% fully satisfied with Zig, then he will name it like version 1.0. And after that, it will no longer break in terms of compatibility. But in order to get there, he really wants it to become a first-class programming language. But there is a huge difference between Zig and Rust, right? So Zig is like a community project. It's like him, the main guy, and a couple of his most trusted developers who are working on it. And he really doesn't. There aren't any corporations involved that control any of that. While with the Rust Foundation, there are a lot of corporations involved, and they all have their say in how things are moving forward. So it's quite a stark difference. and the C language, that's the third version of stark difference, because C has been finalized and completed very, very long time ago, and it's not really changing anymore. It's adding niceties that you can or you don't have to use. I mean, nobody is forcing anyone to use C23 or C17 or C11. You might as well write in C89 right now today, and nobody's going to blame you, because every single compiler that exists today in Ubuntu 26, in Debian 13, in latest Arch Linux, in latest Gen 2, any C compiler that you get, every C compiler is able to compile whatever you write in C89 standard. So from that perspective, all the power to you if you want to write C89. There is nothing wrong with that, and I think it's good even for people like me who are learning, starting today. It's good to learn. I was going to say the old ways and the new way, but what I meant is it's good to understand how things work in this standard and how much the newer standard can help you to make things easier, because every now and then you are going to come up with a code that conforms to the older standard, and it's probably going to be a good idea for you to understand what this code is and not just lean to the latest and greatest you know niceties of the latest standard. Sorry, I was talking for a long time. I'm just catching up with the chat. At Etherweb, that said, I like C23 const expression and null pointer are great to have. Sabot, good evening. Zig is my favorite C replacement so far. I have just issues with debuggers like GD. Okay. As I said, I think it will take a while until Zig is, stable. Visual code support, I don't know about that. C++ designated initializer hamstrung by C++ requirements and class initializer. Zig has good LSP IntelliSense support. Inspecting variables in debugger is where I had problems. Rootlex, welcome in. C++ does have designated initializers. While you guys are chatting, I was thinking about reorganizing my window layout to a degree where chat will not overlap with the code. I think we're good. Okay, so let me just go ahead and just open up where I downloaded this guide from. Okay, library reference. So these two things. Oh, let me actually zoom in a little bit. Okay, so these two things are somewhat connected. You will see that from the text in the book. Do you already know another language and want to learn C? This is the guide for you. This starts with the easy stuff and pointers and gradually adds more content as you progress. Right now, this still includes the library reference, but that is in process of being moved to its own volume below. This is the second volume of Beej's Guide to C, the standard library reference, complete with examples inspired by the incomparable Turbo C Bible. Okay, let me open this shortly to see. What this looks like. We're not going to go through this one today. Most definitely. Iceblade says this one has C23 as well. Yeah. Okay, I don't think this matters today at all. So let's start from here and you will see in the introduction to the book what it feels like. Let's skip all that here. The table of contents. Okay, so I'm gonna read a little bit faster here, and if you need me to slow down and be more understandable, let me know. C is not a big language, and it is not well served by a big book. So the cool guys said that. Let's jump straight into the C code. And they lived happily ever after. Okay, so this is a really nice example example of the C code. What's this? You say something still not clear about this whole C programming language thing. Well, to be quite honest, I'm not even sure what the above code does. It's a snippet. It will take time to decode from one of the entries in the 2001 International Obfuscated C Code Contest, a wonderful competition where the entrants attempt to write the most unreadable code possible with often surprising result. Let's do for fun and shits and giggles, right? What was the duck go? Okay, duck AI. Explain this program, this C program. Yeah, let's see if Claude can do that. Do you guys use Makefile? For the beginning, no, but later. This is a fragment of obscure Golfang. I don't know what this means. C code looks like a part of IOCCC style of competition. Yeah. where they use simple macro definitions to compress everything in the fewest characters possible. Unfortunately, this is only the part of the program. There are missing defines and directives. Boris the Geek, welcome in. Okay. It's a fork bomb. Yeah, it doesn't matter. Just fun. The bad news is that if you are a beginner in the whole thing, all C code you see probably looks obfuscated. The good news is it's not going to be that for too long. Okay. In the old days, C was a simpler language. A good number of features contained in this book and a lot of the features in the library reference volume didn't exist when K and R wrote the famous second edition of their book in 1988. Nevertheless, the language remains small at its core, and I hope I've presented it here in a way that starts with a simple core and builds outward. So the entire book is not new, but it is up to date quite a lot. So that's good. XGUI is asking, is that your main language? It didn't look. Yeah. That was Croatian. Yeah. I told Claude that I want him to speak in Croatian, so he is complying with my wishes. I can override that, of course, but whatever. This guide assumes that you've already got some programming knowledge under your belt from another language such as Python, Java, or whatever. Yeah. So, as far as I understand, everyone in this chat has some programming language under his belt, and it could end up being that I'm the least knowledgeable, but I will do my best because I do understand the basics, like variables, loops, and stuff like that. So it's not like I'm diving in like head through the wall. We already tried with a different book, wasn't perfect, but let's try another one and see if this one will feel better. We're going to assume you know what variables are, what loops do, and how functions work, and so. Okay, so that's fairly where I am at the moment. This part here is a little bit what I'm still working on. I mean, I understand that a function is like a block that does something, and you call it with external call, and well, I mean, I look at it like let's say a black box that I created, so it's not as black, but at the same time it does something, and I call it when I need it to do the thing, right? For LSP, I use Clang. Yes, XGUI4, that's the most popular language server. If that's not you for whatever reason, the best I can hope to provide is some honest entertainment for your reading pleasure. The only thing I can reasonably promise is that this guide won't end on a cliffhanger. Okay, it comes in 2 volumes, and this is the first one, although he said that both volumes are still contained in the first one, so we'll see about that. Library reference in the second volume. If you're new, go through the tutorial part in order generally. The higher you get in chapters, the less important it is to go in order. Okay, so let's stick to the order at first, at least. And no matter your skill level, the reference part is there with complete examples of the standard library function calls to help refresh your memory whenever needed. Good for reading over a bowl of cereal or another or other time. Okay, sorry. Finally, glancing at the index, if you're reading the print version, the reference section entries are in italics. Okay. Platform and compiler. I'll try to stick to plain old-fashioned ISO standard C. Well, for the most part, here and there I might go crazy and start talking about POSIX or something, but we will see. Unix users like Linux and BSD, try running CC or GCC from the command line. You might already have a compiler installed. If you don't, search your distribution for installing some of these lovely compilers here. Windows users, those are irrelevant. Mac users are irrelevant. There are a lot of compilers out there, and virtually all of them will work for this book. And a C++ compiler will compile a lot of C code. Best use a proper C compiler if you can. I'm just kidding a little bit. Windows users, Mac users, if you still Etherweb says C lang D is good, but I prefer CCLS. Iceblade is irrelevant. Yes, yes. The best thing about C is use whatever compiler you prefer. But at the end of the day, I think it's not such a bad idea to check out those other compilers as well every now and then, because I thought that I would and should prefer GCC as my primary compiler. It just seemed to make the most sense. And when I got my first batch of error and warning messages, then I tried with LLVM, I mean Clang, and these error messages seemed a little bit more readable for a human beginner like myself. So I'm not saying that GCC errors are not readable. I'm just saying that from a beginner perspective, it seemed like they generate messages that lead me faster to where I should look for the solution to the problem at hand. I think Iceblade is mostly using what is it called? Linux for Windows subsystem, or is it Windows? I don't know, one of these. So he's almost like in a legit Linux environment, except not entirely. I mean, it's good. If you're using version 2 of the subsystem, then it's basically like a virtual machine. Okay, this guide is copyright him with specific exceptions for source code and translations. This work is licensed under the Creative Commons Attribution Non-Commercial No Derivative Works license. To view a copy of this license, so you all know about the license. I am allowed to upload this document to my website and share it with you from there. I am not allowed to change it, so that's the limit. We can use it, we can distribute it, we cannot change it. Is he Swedish? I wasn't. I don't know. Look him up on the Wikipedia. I'm too lazy to do that right now. Here you go in the chat. Copy paste his name. See where he was born, where he lives. That part doesn't concern me much. I'm just here about the license and how good the book fits this live stream. The hardest thing about writing these guides are learning the material in enough detail to be able to explain it, figuring out the best way to explain it clearly, which seems to be endlessly iterative process, putting myself out there to so-called authority when really I am just a regular human trying to make sense of it, keeping at it when so many other things draw my attention. A lot of people have helped me through this process, and I want to acknowledge these people. Are there any people named here? Not really. Okay. Good. So it here says that C is a low-level language. I would personally not pay attention too much to these kinds of definitions because C may be a low-level language for some JavaScript programmers, but on the other hand, it could be a high-level language for people who made C because they made it high level so that they can make it portable. So from that perspective, it's like a sort of like a high level language. It didn't used to be back in the day when people carved punch cards out of granite. C was an incredible way to be free of the drudgery of lower languages such as assembly. But now in these modern times, current generation languages offer all kinds of features that didn't exist. This means C is a pretty basic language with not a lot of features. It can do anything, but it can make you work for it. Main assembly users, yeah. But you know, assembly is not like I'm trying to say something like I know things, but from what I analyzed so far, it doesn't appear to be very complex. It's actually quite simplistic. It's just that when you start learning it, you have to learn it specifically for this particular processor. This particular processor has specific ways how registers work and stuff like that. So once you learn assembly for this particular processor, you will have a very hard time applying this knowledge to a different processor, and that is a huge pain in the ass, meaning your knowledge isn't very portable. But at the same time, if you are really into some kind of a low level development where the lowest possible access to the hardware is very of very like of utmost importance. I don't know if you are some kind of a programming scientist that is programming the how do you call them? Not processors, but the I'm missing a name. Okay, let's say CPU. You're programming a specific CPU for guiding war missiles, and it is of utmost importance that this missile actually works So there is like 100% chance that you will not be able to write that code in JavaScript. In C, probably yes, but at the same time, if it's like a specific hardware, there may be times when assembly could be more preferred. I'm not saying that it will be, but there still exists some use cases where it could be preferred. And don't get started again for I am the boss programmer because I don't use assembly, which is high level. Like I call the lightning to program the ones and zeros on the spinning platter of my hard drive. XGUI4 is very correct here. Don't overdo it. So why should we use C if it's pretty basic? As a learning tool, not only is C a venerable piece of computing history, but it is connected to the bare metal in a way that present-day languages are not. When you learn C, you learn about how software interfaces with computer memory at a low level. There are no seat belts. You will write software that crashes, I assure you, and that is all part of the fun. As a useful tool, C still is used for certain applications, such as building operating systems or in embedded systems. Though the Rust programming language is eyeing both of these fields. If you are familiar with another language, a lot of things about C are easy. C inspired many other languages, and you will see bits of it in Go, Rust, Swift, Python, JavaScript, Java, and all kinds of other languages. Those parts will be familiar. The one thing about C that hangs people up is, I was not sure if I read it correctly, is pointers. Virtually everything else is familiar, but pointers are those weird ones. The concept behind pointers is likely one you already know, but C forces you to be explicit about it, using operators you've likely never seen before. It's especially insidious because once you grok pointers, they are suddenly easy, but up until that moment they are slippery eels. Everything else in C is just memorizing another way of doing something you've done already. Pointers are the weird bit, and arguably even pointers are variations on a theme you're probably already familiar with. So get ready for a rollicking, I don't know what this means, adventure as close to the core of the computers as you can get without assembly, in the most influential computer language of all time. Give me a sec. I need a lubricant. Ali ne pomaže mi voda. Rutlex says in English, znanje ulazi puno bolje ako ga dobro podmažeš. I'm just joking in Croatian. I translated his sentence to Croatian. Disgusting. Let's see. Let's see where we are in the hello world. We have 3 pages for today. Okay, let's get kicking. This is the canonical example of a C program. Everyone uses it. Note that the numbers to the left are for reader reference only and not part of the source code. Okay, so this book does touch upon a lot of details here. Okay, you have to include I'm going to touch on some obvious things because we already passed some of these things in the previous 3 lessons, but I'm going to pretend somewhat that this is the first lesson and see how that goes. So include is of course important because you need to deal with printf, which comes from standard input output.h. Int main void, and the first block says print f hello world, new line, do something. Okay, I don't believe that this code needs to be copied here, but let's do it like this. Hello.c, good. Okay, so without messing too much with the copying code with my own hands, I will copy it a little bit later, but for now I don't think that's needed that much. Where's my pointer? Okay. We are going to don our long-sleeved, heavy-duty rubber gloves, grab a scalpel and rip into this thing to see what makes it tick. So scrub up, because here we go, cutting very gently. I don't have a scalpel here. I'm not even sure if we can continue without a scalpel. Okay, we'll do without a scalpel. Let's get the easy thing out of the way. Anything between the diagraphs / is a comment and will be completely ignored by the compiler. Same goes for anything on a line after the //. The reason I'm reading all this once again, because someone will rewatch this video on demand sometimes later, and it will seem to him that this is a part, like the first lesson of a multi-part video on demand. So I'm not sure what I'm going to do with the previous 3 lessons. They will probably stay online, but I will put them in another group or something. I don't know. Repetition is good anyway. Yeah. Okay, so this allows you to leave messages to yourself and others, so that when you come back and read your code in the distant future, you will know what the heck it was you were trying to do. Believe me, you will forget. It happens. One thing that the book author didn't mention here, and I believe that everyone in chat already knows it, But just in case if someone else watches video on demand, like absolute beginner, the beginning of C standard, like C89, used this way of making a comment. So beginning of the comment, end of the comment, and you can put this in another line. So whatever it is in between the beginning and the end of the comment will be a comment. But in the later version of standard, of the C standard, the double forward slash was borrowed from C++, I think. And this will not work for you if you tell your compiler to work strictly in C89 standard. So I mean, if you're using any compiler in the year 2026 and beyond, and unless you force the compiler to stick to an older standard, then this will work automatically because most compilers simply default to a newer standards. But I think it is important to understand that this was not always the case. Now, what is this hash include? Well, it tells the C preprocessor to pull the contents of another file and insert it into the code right there. This oil is fucked up. But it works so well. I'm not joking. I wouldn't drink this if it didn't work. Okay. So far, this book is way better. Yeah, it's kind of goofy, I think, is a good word. I guess that gross is about what. Yeah, good timing. No, the point. This is olive oil. This is literally virgin olive oil from my village, and it's disgustingly strong. It's really strong. And the reason why this works for me is because it kind of sticks to my throat, and it stays there. Not all of it, of course, but a good film remains for quite a while, and this is what helps me to not. I don't know how to explain what happens to me, but I start coughing, and it's hard for me to talk for too long. If my throat is completely dry, and although water helps a little bit, water goes entirely through my throat, right? So if I don't drink it all the time, it doesn't lube the throat. It is what it is. Okay, so wait, what is a C preprocessor? That's a good question. There are two stages to compilation: the preprocessor and the compiler. Anything that starts with pound sign, hash symbol, or octorp. I have never seen this word in my life. Octo. How is this being pronounced? Octotrp. I have no way to understand. Octotorp. Octorp. Okay, so I think it's octorp. Sorry for trying so many times, but I literally see this for the first time. I think this is a very popular name for the Brits for obvious reasons. but I just kind of default to hash. It seems like the most people know it. Okay. Iceblade says octo the rope. Okay, anything that starts with a hash symbol is something that preprocessor operates on before the compiler even gets started. Common preprocessor directives, as they are called, are include and define. More on that later. So before we go on, why would I ever begin to bother pointing out that a hash sign is called an octorp? The answer is simple. I think the word octorp is so excellently funny, I have to graciously spread its name around whenever I get the opportunity. Octorp, 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 octorp. I must admit that the author of this book kind of persuaded me with this just one sentence here that from now on, this is octorp. Okay, XGUI4. I think we can all agree that this indeed is octorp. Okay. Look, I am Slav. Okay, I am Slav, and the way we pronounce stuff, maybe I can ask some Brit how they would pronounce this, but after many attempts, this is going to be octorp, which ends abruptly, like I said, octorp. So anyway, after the C preprocessor has finished pre-processing everything, the results are ready for the compiler to take them and produce assembly code, machine code, or whatever it's about to do. Machine code is the language the CPU understands, and it can understand it very rapidly. This is one of the reasons C programs tend to be quick. Don't worry about the technical details of compilation for now. Just know that your source runs through the preprocessor, then the output of that runs through the compiler, and then that produces an executable for you to run. So what about the rest of the line? What's the stdio.h? That is what is known as a header file. It is the .h at the end that gives it away. In fact, it is the standard IO, stdio, header file that you will grow to know and love. It gives us access to a bunch of input-output functionality. For our demo program, we are outputting the string hello world, so we in particular need access to the printf function to do this. The stdio.h file gives us this access. Basically, if we tried to use printf function without octorp include, the compiler would have complained to us about it. How did I know I needed to include stdio.h for printf? Okay, that's a really good question. Answer, it's in the documentation. If you are on a Unix system, man3 printf and it will tell you right at the top of the man page what header files are required, or see the reference section in this book. Okay, man3 printf. So synopsis: include stdio.h and a bunch of examples. Holy moly, that was all to cover only the first line, but let's face it, it has been completely dissected. No mystery shall remain. So take a breather, look back over the sample code, only a couple easy lines to go. Let's go and do what it says, what he says. Okay, so that's the include, and we now have int main void, and then our main block starts. Are we back from the break? Right, good. Welcome back from your break. I know you didn't really take a break, I was just humoring you. The next line is main. This is the definition of the function main. Everything between the squirrely braces. Squirrely? Is it? Was it not? What did I say the last time? Squirrely. They were not called squirrely. Curly. Yeah, curly. Okay, that seemed like a different word to me, but I don't mind changing the word. I'm just sometimes surprised. Okay, so everything between the curly braces is part of a function definition. How do you call a different function anyway? The answer lies in the printf line, but we'll get to that in a minute. Now, the main function is a special one in many ways, but one way stands above the rest. It is the function that will be called automatically when your program starts executing. Nothing of yours gets called before main. In the case of our example, this works fine since all we want to do is print a line and exit. Oh, that's another thing. Once the program executes past the end of the main, down there at the closing squirrely brace, the program will exit and you will be back at your command prompt. So now we know that the program has brought in a header file stdio.h and declared a main function that will execute when the program is started. So what are the goodies in main? So one thing I need to dissect additionally is how well is this shown on the screen. I think it's good, although I can make it a little bit bigger because it's not that big. Size, okay, this is max that my screen can take. I think make it smaller. Okay, int main void. I believe that in newer C standards, it is very important to start the main function by declaring it as integer, while in C89, and you guys are going to help me with this, I'm not sure if this even works, or if it does work, I think it wasn't necessary, the int part. In C89, was it necessary to write int here? I think not. XGUI4 is asking, why is the C need a \n at the end of the string? It's not necessary, but this is a new line. This tells your program to write hello world and then go to the new line and then do the rest of the code. And since there isn't anything else, then it will it will put you back into your command prompt. But if you don't put the \n, then your command prompt might end up in the same line as hello world. Actually, let's do that right now. I think this is a very good exercise. Compile it, run it again, see what happened. So now we didn't have go to new line. So once we outputted hello world, we just continued into the command line without the new line. So it is absolutely your choice whether you want a new line or you don't want the new line. You are the programmer, you get to decide. A lot better example would be inside your program. For example, when you are expecting an input from the user, you type printf like under quotes, what is your name, like question mark, space, and end quotes, and then you don't put the \n because you want your user to input his name in the same line in the continuation of the what is your name question mark. So then you type Dart, enter. But in some cases you will want the reply from the user to be typed from the beginning of the next line. That's completely up to you. You get to decide if you want the new line or not. Let me go back to my question for a moment. Okay, in C89, no int wasn't strictly required syntactically, though it's what the standard specifies as correct. Oh, Rootlex already replied, no int there is very old legacy when undeclared functions were assumed returning int. Just always specify the return type. Yeah, so from C99 onwards, omitting int before main is a constraint violation and compilers must diagnose it. Mind you, I am not at all advocating for omitting this. It's just that some of these details, when I notice them, I think it's good to point them out whenever I have the opportunity, because I think it's good. I mean, if you see someone's code that doesn't have int, maybe you can tell that person to put it there to make the code better, or you can ask him if that's an, I don't know, an older code or something. It's just that it could be that some programs would not have it, right? Yeah. I also believe that in K and R book there wasn't. Let me see if I have that book somewhere nearby. Actually, where's my what's the name of the Calibre? I have it in Calibre, I think. The programming language. Getting started. Right. Okay. This is from the original book from the guys K and R. Getting started. So this is their example of hello world. You know, so you can argue this being good or bad, it doesn't really matter. It's just a fact that this was a thing at the time. And this is the book that I wanted to use for this class. Simply because it's a cult classic, not because it's the best. That's another thing. Once the program executes past the end of the main, down there at the closing squirrely brace, the program will exit and you will be back at your command prompt. So now we know that the program has brought in a header file and declared a main function that will execute when the program is started. What are the goodies in a main function? I'm so happy you asked. Really, we only have the one goodie, a call to the function printf. You can tell this is a function call and not a function definition in a number of ways, but one indicator is the lack of squirrely braces after it. I must say, this way of explaining things is really good because this is the exact question that I asked you guys in one of the last streams. Maybe it was the second one, maybe even the first one, when I got confused between what is or isn't a function, because that book, the modern C book, didn't quite do the best job in presenting it, right? And nothing really stops the book author from iterating on the book and making it easier on people to have their questions answered immediately, because you know, very quickly, if you don't know things, you will get to the part where you ask these kinds of questions, and the question has been answered before I would get a chance to even ask it. So kudos to this author. Yeah, so definitely. So it's a function call and not a function definition, because there aren't any squirrel. Okay, I suppose I'm gonna read it like this from now on. Squirrely braces. And you end the function call with a semicolon, so the compiler knows it is the end of the expression. You will be putting semicolons after almost everything, as you will see. you are passing one argument to the function printf, a string to be printed when you call it. Okay. Oh, yeah, we are calling a function. We rock. Wait, don't get cocky. What's that crazy backslash? Okay, so another example where this author is like really good, and I think XGUI4 is going to be very happy with the way this book has been written. Okay, so what's that crazy backslash n at the end of the string? Well, most characters in the string will print out just like they are stored, but there are certain characters that you can't print on the screen well that are embedded as two-character backslash codes. One of the most popular is backslash n, reads as a backslash n, or simply new line that corresponds to the new line character. Lajka, šta radiš to? Lajka, gdje je muha? Tu ti je muha, tu je. Tu je muha. Nađi. Ajde, nađi. Nađi muhu, ajde. Nađi muhu. My dog found a fly in the room and he's trying to catch it, but my dog has feet this long. Jumping is not one of her skills. So she just makes a mess everywhere. This is the character that causes further printing to continue at the beginning of the line of the next line instead of the current line. It is like hitting return at the end of the line. Flash Webby, welcome in. LOL. Yes. So copy that code into a file called hello.c and build it. I feel like I am one step ahead with this, and I didn't even, I mean, it was obvious, but I decided on my own. Okay, I got something important. Holy shit. Give me just a second. I'm selling something. I'm selling something and someone just offered me a price on the item that I'm selling. You know, this is a little bit shit because I'm just gonna take a small break here. I'm selling Xbox because I haven't been using it for years. It's just standing there, and one guy asks me if he can come and pick it up tomorrow for a slightly smaller price than I'm asking, and I said fine. And another guy is just now sending me an offer for the same price, but this one is trying to pay me immediately. So I think I'm just gonna accept it immediately because, you know, first come, first serves. Golga Katani, good evening. What is the size of the package? Fucking shit, now I have to measure the package. Give me just a second, just a second. Okay. Of course, we get derailed by things like normal. I'm trying to collect some money for the car. That sounds like a silly thing to say because I'm selling small things for a couple of €100. But these things add up, and it helps me with finances quite a bit. It's not an insignificant amount of money when you sell like 2 laptops and a console and maybe a computer. I have stuff that I don't use. Um, uh, you just don't sell your hat, it's priceless. You just reminded me, I need to tell my sister to get me one more. Sorry for showing my Telegram on screen. Where is my sister? Tells Xbox buy a hat. Honestly, I'm sorry for derailing this. I love Xbox Series X hardware. That box, as it came out in 2020, it's absolutely awesome mini PC. It felt like a really perfect kind of a mini PC. It's just that I didn't use it all that much, and when I kind of got involved completely into gaming on Linux, I just stopped using it, and I really feel stupid for owning stuff whose value is just going down over time, and eventually it's going to be useless. And at the same time, the entire box is completely a closed black box, and you cannot install anything else on it. If I could install Linux on it, that would be awesome, and I would most probably do that because, as I said, it's a good PC in terms of hardware. It's really good. Um, I'm not arguing for people who have the use for their consoles. That's all good and fine. I'm just saying it's collecting dust. I don't need it anymore, and I'd rather get this amount of money now than that amount of money in a year when the next one gets announced. That's all. Helix is the next textbook. It doesn't matter. I'm just saying the one that I currently have, I don't need it. I want it out of my face. I want some money for it, and let's get on with life. I'm also selling my Steam machine wannabe because I'm trying to see if it's worth. I think I'm asking quite a lot for it, but then again, um, it all depends on what the market value is at the moment. Because if I can only add like €200 after selling my own version of Steam machine, and get the actual one, I would probably want to do that because I'm very much interested in that Valve experience. But let's get that out of the way for now. We can talk after the stream. Okay, copy it, build it on a Unix-like platform. From the command line, you will build with a command like gcc-o hello and hello.c. This means compile hello.c and output with -o an executable called hello. After that is done, you should have a file called hello so that you can run with this command /hello. Deleting // tells the shell to run from the current directory and see what happens. If you guys remember Golga Katani, yeah, we switched to a much lively book, and this is the lesson number 1. We kind of already agreed on the last stream that the last book wasn't perfect for this stream format. And actually Rootlex found this one, and there was a third one, and somehow the way this book presents things is better. You know, I wanted to say there are fewer questions remaining in the air, but so far there are 0 questions remaining with all these explaining in detail that this author does, and it's pretty good. Stick with us and see how it is. If you guys remember from our LPIC sessions previously with Bash programming, if you want to run from a current directory, you type /hello in order to run this compiled program, but also you can just type bash space hello in order to execute the command with bash. You appreciate this? Yeah, I think so far everyone appreciates this book. Also, you don't really need -o hello because if you omit the output file name, then the output file name will be the default one that is called a.out as presented. Let me see if you can see this. Yeah, it's slightly visible below the chat. Okay, so in my examples, I prefer to omit the file name when I'm doing really small examples because it feels like a waste of time on really small examples that are otherwise useless. But once you start making some tangible things, then of course you will want to have a meaningful file name. It's just that you should be aware that you absolutely can omit the file name, and you should know what is going to happen if you do that. It's done and tested. Ship it. Okay, compilation details. Let me just see. Okay. Let's talk a bit more about how to build C programs and what happens behind the scenes there. Like other languages, C has source code. Staj lajka? Ćeš doći tu? Hoćeš doći tu? Huh? Maybe for the next stream, I can prepare a second camera which records my dog, because whenever I'm streaming, my dog usually comes and lies down on the bed here. And she really doesn't like to sit in my lap here because there isn't too much space here for her to be comfortable. But she likes to be there on the bed and just watch over me. But she's really interested in what I have to say. Dog cam, more space to block that. I have an idea for that. I can squeeze the thing. Okay. Like other languages, C has the source code, but depending on what language you're coming from, you might never had to compile your source code into an executable. Compilation is the process of taking your C source code and turning it into a program that your operating system can execute. JavaScript and Python developers aren't used to a separate compilation step at all, though behind the scenes it is happening. Python compiles your source code into something called bytecode that the Python virtual machine can execute. Java developers are used to compilation, but that produces bytecode for the Java virtual machine. When compiling C, machine code is generated. This is the ones and zeros that can be executed directly and speedily by the CPU. Okay, then it says languages that typically aren't compiled are called interpreted languages. But as we mentioned with Java and Python, they also have a compilation step. And there is no rule saying that C can't be interpreted. There are C interpreters out there. In short, it's a bunch of gray areas. Compilation in general is just taking source code and turning it into another more easily executed form. The C compiler is the program that does the compilation. As we have already said, GCC is a compiler that is installed on a lot of Unix-like operating systems, and it's commonly run from the command line in a terminal, but not always. You can run it from your integrated development environment as well. So how do we do command line builds? If you have a source file called hello.c in the current directory, you can build that into a program called hello with this command typed into your terminal. So we have already done something like that. The -o means output to this file, and there is hello.c at the end, the name of the file we want to compile. If your source is broken up into multiple files, you can compile them all together almost as if they were one file, but the rules are actually more complex than that. So by putting all the .c files on the command line, gcc-o awesome game, UI.c, characters.c, npc.c, item.c, and they will all get built together into a one big executable. That's enough to get started. Later, we will talk details about multiple source files, object files, and all kinds of fun stuff. Building with Slung. On Macs, the stock compiler isn't GCC, it's Slung. but a wrapper is also installed, so you can run GCC and have it still work. The book title? You are asking... Oh, the Black Elephant, welcome in. The book title is Beej's Guide to C. Okay. I don't know how to pronounce Beej. Beej from South Sudan, by the way. Welcome in, welcome in. We are going through Beej's Guide to C Programming. Let me see if I can help you out. Copy, paste. You can freely download it from here. It's not a paid book, but it seems to be a really good one that explains things in quite a lot of detail. Building with Clang. Okay, so here you can download it for yourself and follow along whenever you want. Okay. You can also install the GCC compiler proper through Homebrew or some other means. If anyone is interested what Homebrew is, or if there are any Mac users in the chat, let me know. I can somewhat explain this. Also, Homebrew exists on Linux as well, as you can see here. So whatever Mac users are doing with Homebrew on a Mac, you can do the exact same thing as well on Linux. It's just that we Linux people are used to doing things on many different ways. So if you like it, good. If you want to do it differently, also good. If you are using IDE, you are probably not having to build from the command line. With Visual Studio, Ctrl F7 will build and Ctrl F5 will run. With Visual Studio Code, you can hit F5 to run via the debugger. You will have to install the C extension. With Xcode, which is a IDE from programming on a Mac, you can build with Command B and run with Command R. To get the command line tools, Google for Xcode command line tools and you will find instructions for installing them. For every getting started, I encourage you to also try to build from the command line its history. Iceblade didn't know the shortcuts, just use terminal inside Visual Studio Code to compile. That's a bit odd, I must say, because the first thing what I do when I installed any IDE is I kind of go through the main set of menus and see what it has, and almost always it has a compile and run option in the menu and what the shortcut is. Also, when I set up Emacs as my how do you say it in English? Let's say when I set up my Emacs to pretend to be an IDE, and by some definitions of what IDE is, I did have Emacs in IDE mode. you can easily bind keys to compile, just press F5 if that's what you like, or some other key combination, whatever. I'm not saying which combination you should put. It's just that you can even program Emacs to do your bidding, whatever you like, right? You are now working on your code. This key combo will compile and run in a additional, terminal window inside Emacs. This key combo will run a GDB debugger in a visual mode inside Emacs with like a split screen when you will see like where does your code jump from which assembly line to which another one, where you currently are in your C source code, what is happening with your code, and you can like execute little by little. Like Emacs has the debugging procedure in a very visual way. So I think that program is like a good middle ground between doing everything in the command line and suffering a little bit of that rawness, and using like a Visual Studio overkill that maybe not an overkill later in your programming life, but in the beginning, everyone is different, right? So whatever I wanted to say is that Emacs has pretty nice looking GUI, and by GUI I don't mean something that necessarily needs to run in X11/Wayland. I mean GUI in a terminal, even like a visual representation of what's happening under the hood. And now we have proprietary talk here. Yes, I agree, XGUI4. It's just that I think it's good to understand how the command line works, but at the same time, once you go through the command line and once you understand how it works, I think it will speed you up to level up your development environment with something that will provide you with some shortcuts and speed you up. That's all. Also, I'm not sure about NeoVim, but Vim has an integrated terminal. Sorry, Rootlex. C has come a long way over the years, and it had many named version numbers to describe which dialect of the language you are using. These generally refer to the year of the specification. The most famous are C89, C99, C11, and C23. We will focus on the last one in this book, but here are more complete table. K and RC, the 1978 original, named after the authors. C89, ANSI C90 from the American National Standards Institute. C95, rarely mentioned version. The first big overhaul with lots of language additions. The thing most people remember is addition of the / style comments. As I keep repeating, I keep being amazed but how much into details this author is going, because I'm kind of losing the point of me saying anything that I know, it's being lost in this book because this author tends to cover everything. Now, whatever I came up so far, he covers it sooner or later. Okay, this is the most popular version of C in use as of this writing. C11, this major version update includes Unicode support and multi-threading. Be advised that if you start using these language features, you might be sacrificing portability with places that are stuck in C99 land. But honestly, C99 is getting to be a while back now. XGUI4, I have already said this in the beginning of today's live stream. Double forward slash for comments was borrowed from C++ in the standard C99. So no, it didn't work in the original C. C17 is like a bug fix update, but the publication, blah, 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 whatever. And C23 is the most recent specification. You can force your compiler to use one of these standards with the -std equals command line argument. If you want to be picky about the standard, add -pedantic. For example, GCC standard is C11 pedantic foo dot C. So this compiled perfectly fine. Let me just try a couple more examples of being pedantic about the standard here. Let's go with 89 and being pedantic about it. And it says error, C++ style comments are not allowed in ISO C90. Actually do the work over here. So hello.c on the line number C. Where is the line? Actually do the work here, right? So this comment here no longer works because we're trying to compile with an old standard. I think this is a good enough example of how things are changing and how the compiler is behaving towards your desire to be pedantic about the older standard. For this book, I compiled programs for C23 with all warnings set. Okay, so GCC-wall-w extra standard equals C23-pedantic. Okay, so let's do that one more time on the hello.c. Okay, but as well, if I omit this, it will be the same because my compiler defaults to C23. Yeah. Who are these pirates? It takes all kinds to make a world, does it not, padre? So it does, my son. So it does. There sure can be lots of stuff in a C program. Yep, and for various reasons, it will be easier for all of us if we classify some of the types of things you can find in a program so we can be clear what we are talking about. Variables. Oh shit, did we switch to the next lesson? We did. Oh. Shit. Guys, make a decision right now. Do you want me to go through variables today and compress it into lesson like number 1? It's like a chapter 3 already, but this stuff is so easy that I think I think everyone will compress it. Yeah, we continue. I thought so. I'm just asking. Yeah, let's go through variables. Chapter 3. Iceblood agrees as well. Flash Webby agrees. Golga Katani agrees. The Black Elephant agrees. Good, good, very nice. It is said that variables hold values, but another way to think about it is that a variable is a human readable name that refers to some data in the memory. We're going to take a second here and take a peek down the rabbit hole that is pointers. Don't worry about it. You can think of a memory as a big array of bytes. Data is stored in this array. If a number is larger than a single byte, it is stored in multiple bytes. Because memory is like an array, each byte of memory can be referred to by its index. This index into memory is also called an address or a location or a pointer. When you have a variable in C, the value of that variable is in memory somewhere at some address. Of course, after all, where else would it be? But it's a pain to refer to a value but by its numeric address, so we make a name for it instead, and that's what the variable is. The reason why I am bringing all this up is twofold. It is going to make it easier to understand pointer variables later. They are variables that hold the address of other variables. Also, it is going to make it easier to understand pointers later. So a variable is a name for some data that is stored in a memory at some address. You can use any characters in the range 0 to 9, A to Z, and underscore for variable names with the following rules. You can't start a variable with a digit. It's more from the roots, Golga Katani, yeah. You can't start a variable name with 2 underscores. You can't start a variable name with an underscore followed by a capital A to Z. For Iceblade says, think all variables had to be snake case. I think you can use camel case as well. I don't see the reason why not. For Unicode, just try it. There are some rules in the spec in D2. What is D2? I'm not sure. That is just a convention, just be consistent. XGUI4 says true, but I mean like for spaces. Who is preventing you to not use spaces and do the camel case thing? Anyways, there are some rules in the spec that talk about which Unicode code point ranges are allowed in which part of identifiers. But that's too much to write about here and is probably something you'll never have to think about anyway. Depending on which languages you already have in your toolkit, you might or might not be familiar with the idea of types, but C is kinda picky about them, so we should do a refresher. You can't put a space inside variable. Yeah, of course you can't, but I'm saying you can use camel case. Words, multiple words being one variable name without spaces. Camel case. One big letter, one caps for the beginning of every word that consists one variable. I made a small mistake with the A, but that's just how I type on my keyboard. Sorry about that. It's just a typo. Golga Katani is actually onto something because the way he used camel case is also compatible with the variable name starting with a number. Because you're not allowed to put a caps after a leading number. So in that case, Golga Katani is doing it a little bit better. Okie dokie. Some example types, some of the most basic. Integer, example 3490. C type int. Floating point, example 3.14. This is a float for the pi. Character, single. Example C under single quotes. This is car. Ice blade, yep. But look here. Oh, sorry, I'm wrong. Sorry, I was wrong. You can't start a variable name with an underscore followed by a capital letter. It was about underscore, not about the number. But you can't start a variable with a digit at all. So your example is wrong, but for a different reason. I mean, the compiler will complain, so you will learn eventually. I mean, when I say you as a plural, me included. String, hello world, under double quotes, character, I suspect of a pointer type. C makes an effort to convert automatically between most numeric types when you ask it to, but other than that, all conversions are manual, notably between string and numeric. Almost all of the types in C are variants on these types. Before you can use a variable, you have to declare that variable and tell C what type the variable holds. Once declared, the type of variable cannot be changed later at runtime. What you set it to is what it is until it falls out of scope and is reabsorbed into the universe. Let's take our previous hello world code and add a couple of variables to it. Okay, so in here, int main void, int I holds some signed integers, example, blah, blah, blah. Float f holds some signed floating point numbers, okay? So this is where we have defined a couple of variables here and their types over here. So we have declared a couple of variables. We haven't used them yet, and they're both uninitialized. One holds an integer number and the other holds a floating point number. A real number, basically, if you have a math background. Uninitialized variables have how do you read this? Indeterminate value. They have to be initialized, or else you must assume they contain some nonsense number. This is one of the places C can get you. Much of the time, in my experience, the indeterminate value is 0, but it can vary from run to run. Never assume the value will be 0, even if you see it is. Always explicitly initialize variables to some value before you use them. This isn't strictly 100% true. When we get to learning about static storage duration, you will find the some variables are initialized to 0 automatically, but the safe thing to do is always initialize them. So what is this? You want to store some numbers in those variables. Insanity. Here I noticed something interesting. I'm lying here a little bit. Technically, 3.14159 is of type double float, but we are not there yet, and I want you to associate float with floating point, and C will happily coerce that type into a float. In short, don't worry about it until later. Read this as pointer to a car. 44444. Yeah, that's this pointer to a car. Pointer to a car or car pointer. Most people pronounce this as car, but minority just says car. I don't know, this is the same word to me. Let's go ahead and do that. Int I, okay, a variable initialized. Ch is pronounced differently, like in chat. Yeah, but the problem, where is it? The problem is, how would it sound if I pronounce this as char? Char, 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 char. If you guys want me to pronounce this as char, I am fine with that, but don't expect me to pronounce it like a Brit. I will pronounce it like a Croatian. Closer to real. Yeah, it's a char for me. Okay. I has been initialized. Do as you wish. Thank you. Int I, and then I is 2. Assign the value 2 into the variable I. Killer. We have stored a value. Let's print it. We are going to do that by passing 2 amazing arguments to the printf function. The first argument is a string that describes what to print and how to print it, called the format string. Okay, so here we are coming to some really interesting stuff. And the second is the value to print, namely whatever is in the variable I. Printf hunts through the format string for a variety of special sequences which start with a percent sign that tell it what to print. For example, if it finds a percentage %d, then it looks for the next parameter that was passed and prints it out as an integer. If it finds a percentage %f, it then prints the value out as a float. If it finds a percentage %s, then it prints a string. As such, we can print out the value of various types like so. Variable initialized with the value. Char, what did we say? How do we read this? Pointer to the variable s. It would seem equals hello world, pointer to a char. Okay, or char pointer is the string type. I appreciate, yeah, I absolutely appreciate you guys for helping me in the chat, and that is what I want. But I also must notice that whatever question I came up with, it seems to be answered really fast in this book. I really didn't see this when I asked my question, because I was reading from this side and I was thinking out loud about how to read it. Anyways, printf, open parentheses, quotes, percentage %s, I equals percentage %d, and f equals percentage %f. And then we go to the new line and we gather our variables. It reads from right to left. Okay. And the output will be hello world. Print this one. I equals 2. So the second variable is being taken from the second position here. This is the first variable taken from here. Second variable taken from here. And the third one taken from here. And of course, these guys are taken from their previous definitions. I think at this point the book explains it better than I do, but XGUI 4, I feel like you are here for the first time for longer than 5 minutes. I do appreciate that, but if you have any questions so far, let me know. In this way, printf might be similar to various types of format strings or parameterized strings in other languages you are familiar with. Note, in the following sections, I just assume that you have declared the variables ahead of time. If the example uses integers I and j, just assume somewhere above the example I had int I j, so they have been initialized as integers. C has Boolean types true or false. 1 declared but uninitialized. Historically, C didn't have a Boolean type, and some might argue it still doesn't. In C, 0 means false and non-zero means true. So 1 is true and minus 37 is true and 0 is false. You can just declare Boolean type as int s. So int x equals 1 if x sorry, I have a little bit trouble deciding how to read this. If x is print f x is true, then go to new line. XGUI is asking a enum can also be used, like enum true, false, right? Your question is about to be answered. I can already see it here. I remember in the Matrix chat, you saying something about how you consider C23 to be too new. Like, it's so new that like it's only 2 years old and you don't want to use it yet. But at the same time, it does have some of the goodies. So if you're the one doing the programming, it doesn't really matter. I think that you're using the latest standard. I was going to go deeper into this, but then I remembered Rootlex saying, please don't stop for that long. But anyways, I think using the latest standard is not a problem anymore. If you have access to GCC 15, that one defaults to C23. So if it defaults, then, you know, but can the standard reduce retro compatibility? I mean, if you make your program in C23 standard, and for example, you publish it on GitHub, and your program becomes important enough that Arch Linux includes your program into their repository. So your program is now going to have a Arch maintainer, and this Arch maintainer is going to use GCC 15 most likely, because that's the current version, so it's obviously in Arch Linux. And that maintainer will have zero issues compiling and packaging your C23 application in Arch Linux. At the same time, Debian 13 maintainers will also not have issues with compiling your program, even with GCC 14. So from that perspective, you are also good. So where does the break happen? The break could happen if you give your source code to someone who is using some really old system that does not have a newer compiler. Is that a problem? Is that an actual problem? I don't know. It's not a problem for you who is making this program because you have the compiler. It's not a problem for package maintainers of various Linux distributions. So who is the problem for? I don't know. You tell me. There will be some edge cases for sure, but overall, I'm not sure if I see the problem. Anyways, in C23, you get the actual Boolean or bool, true and false. Before that, if you have a modern enough version of C, you can include stdbool.h to get the same thing. Okay. Int main void bool x equals true, blah, blah, blah. So x is true. While technically you should be setting a bool variable to true, false, or the result of some expression that evaluates to true or false, you can actually convert all kinds of things to bool. There are some specific rules, but zero-ish things tend to evaluate to false, and non-zero-ish things tend to evaluate to true. Zoran, a long time no see. Zoran, how are you? XGUI Studio is asking, can I make a game for Amiga using C23? I don't see why not. If you're going to use GCC compiler or LLVM CLang, the latest version on Linux, and you will tell your compiler to make a binary for Amiga, and then you will take the binary and just copy it to Amiga and run it from there. In that way, yes, you can use C23 on to make software for Amiga, but you most likely cannot use C23 code and compile it on the Amiga OS, because most likely there isn't a C23 compiler on that operating system. I'm good, Zoran. We have switched kind of to learning programming, so we are having fun. Stick around and have some fun with us. XGUI4, I believe the term is called cross-compiling. When you tell your x86 Linux 64-bit compiler to compile the binary not for your computer, but for a completely different architecture. Did I read this? Yes, I did. But be careful if you mix and match, since the numeric value of true is 1, probably, and if you are relying on some other positive value to be true, you might get a mismatch. For example, printf %d true equals 12 prints 0 false. Sorry, taking a little bit break. Operators and expressions. C operators should be familiar to you from other languages. Let's blast through some of them here. Iceblade is asking, can he make how did you write that? Can you do the I don't know how to read what you wrote. C operators should be familiar to you from other languages. There are a bunch more in details than this, but we're going to do enough in this section to get started. Arithmetic. Hopefully these are familiar. I equals I plus 3. So this is addition. I equals I minus 8 subtraction. I equals I times 9 multiplication. Division. I equals I percentage 5. This is modulo, the remainder of the division. Okay. There are shorthand variants for all of the above. Each of those lines could more tersely be written as I plus equals 3, I minus equals 8, and so on. This is a matter of practice, being the same thing as the above. There is no exponentiation. You will have to use one of the POW function variants from math.h. So I'm pretty sure this means power off. Let's get into some of the weirder stuff you might not have in your other languages. Ternary operators. C also includes the ternary operator. Rootlex, help me out once more. What is this shit? This is an expression whose value depends on the result of a conditional embedded in it. Maybe the book will manage to explain it this time, because the last book got me puzzled very, very, very much. An expression whose value depends on the result of the conditional embedded in it. If x is larger than 10, add 17 to y. Otherwise, add 37 to y. Look in the box. I'm looking in the box. Y plus equals x bigger than 10, question mark, 17, colon, 37, semicolon. What a mess. You'll get used to it the more you read it. To help out a little bit, I will rewrite the above expression using if statements. Y, I have already read that, is equivalent to this unknown expression. If x is bigger than 10, then y equals plus, it's hard to read this one, but it is what it is, else add 37 to y, as it said above. I'm trying to compare those two until you see each of the components of the ternary operator. Okay, so it says if x is bigger than 10, I mean, it seems to be readable to me because it's so small of a code. But I think I would need to practice this before I get the grips. It's basically, I'm reading Rootlex's message. It's basically condition. Okay, condition. So y plus equals x bigger than 10. And then question mark. If true, if not true. But if true and if not true are the ones that are in the in the variable, right? Is not. Oh, so 17 replaces the x then. Read it like y plus equals, oh, with okay, with the braces, the round ones. Okay, okay, x is bigger than 10, Then, okay. On another example, hopefully it will sit better, that prints if a number stored in X is odd or even. So printf, the number %d is %s. So we have X. We have X here as the first variable. And then the second one is everything here that gets replaced with %s. So basically it says if x modulo of 2 is 0, basically if I can divide it and end up with 0, then I'm a little bit confused. Then it's the first result, and if that's not true, then clearly it's odd. Okay, now I'm getting some sense here. Okay. The %s format specifier in printf means print a string. If the expression x %2, sorry, I need a reminder for myself. Funny to see someone else struggle understanding something I feel superior. Yes. Opposite, well, we do Linux. It's good. I appreciate you being here for me. Iceblade. The %s format specifier in printf means print a string. In the expression x modulo 2 evaluates, if the expression x modulo 2 evaluates to 0, the value of the entire ternary expression evaluates to the string even, otherwise it evaluates to the string odd. Pretty cool. It is important to note that the ternary operator isn't a flow control like the if statement is. It's just an expression that evaluates to a value. Now, let's mess with another thing that you might not have seen. These are the legendary post increment and post decrement operators. I plus plus and I minus minus. Add 1 to I post increment, subtract 1 from I post increment. Very commonly, these are just used as shorter versions of I plus equals 1, add 1 to I minus equals 1, subtract 1 from I. Part 2, Revenge of Iceblade. Now I need water. I wanted to say something to Zoran, but looks like Zoran is no longer here. Okay, but they are more subtly different than that, the clever scoundrels. Let's take a look at this variant, pre-increment and pre-decrement. Plus plus I, minus minus I. Add 1 to I, pre-increment, subtract 1 from I, pre-decrement. With pre-increment and pre-decrement, the value of the variable is incremented or decremented before the expression is evaluated. Then the expression is evaluated with the new value. With post-increment and post-decrement, the value of the expression is first computed with the value as is, and then the value is incremented or decremented after the value of the expression has been determined. Okay, so far this is pretty clear to me. I don't see any room for misunderstanding this part here. If anyone else thinks it's not as clear, let me know so we can continue. Basically, when you will be doing something like for loops, you will be using this counter or this counter. So whether you will execute shit first and then increase the counter, or you will execute stuff after increasing the counter, that's up to you, depending on how long you will want your for loop to be looping. It could loop one loop longer than you want if you do it the wrong way. Make sure to read comments in the following blocks. Okay. You can actually embed them in expressions like this. I equals 10. J equals j equals 5 plus I plus plus. So this means compute 5 plus I and then increment I. So printf will print 11 and 15 here. Let's compare this to pre-increment operator. So in this case, we will do the same calculation, but we will first increment the I to 11 and then compute 5 plus 11 here. So we get 16. Basically, this is the thanks rootlex. This is basically the same what I said about the for loop. Thinking ahead about how long you want to loop your for loop, because it all depends on when your loop variable, if I can call it that way, will reach its final number. But yeah, this is really fancy. Plus plus I plus plus. This technique is used frequently with array and pointer access and manipulation. The book tries hard to explain things. Good, good, good. One more time. This technique is used frequently with array and pointer access and manipulation. It gives you a way to use the value in a variable and also increment or decrement that value before or after it is used. But by far the most common place you will see this is in a for loop. For I equals 0, I is smaller than 10, I plus plus, print shit over here. So in this case, it will do the thing, and only then it will increase the number and it will loop once again. So it could end up, if you as far as I understand it, if you rename this to plus plus I, then this will result in this for loop looping 1 times more than it does now. Here it doesn't matter. In this case, no, because it's behind a semicolon. But more on that later. Because both I++ and ++I will be executed separately after each loop, they are not parts of other expressions. I'm not entirely sure. It's not that I don't believe you, it's just that I want to feel it. Ah, okay. What's wrong? Undeclared I. Okay. I'm learning. I equals 0. Okay, now it works. I is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 times that it has gone through the printf. And I have moved the pluses in front of the I. Huh. Interesting. Check my other comment above. What you are saying will be true if you write I++ less than 10 in the... you need main. Oh, no, okay, so whatever. You need Yeah, that part I figured out by myself, but yeah, so you need to use the I variable in some kind of comparison. In here, it's just being used for counting loops and nothing else, so it's not really interacting with anything. Okay, I think I got it, but just as well, it how do I say it? It felt important for me to give it a try and see it for myself. Basically, if you don't assign I plus plus or plus plus I to anything, then it doesn't matter if I is incremented before or after. Okay. Okay. But nevertheless, I really like to try things out that, how do I say it? When I was really self taught, and I did make some programs in my life, better or worse doesn't matter, but I did finish some things. Most of it I would kind of iron out by trial and error. Like, this shit doesn't work. I thought it should. Let's make it in a different way, and then you come up with a solution eventually. And as you come up with a solution, on the path of getting to the solution, you learn things, and at the very least, you learn this shit called experience. Yeah, I believe you. I believe you. We will get to your example pretty fast. I am sure, because it says here, but more on that later. I think we should be good. No. I said the shit, ex GUI. So, in English slang, shit and the shit have almost opposite meanings, even though they look similar. Shit is something negative, means something is bad, poor quality, disappointing. This movie is shit, it's terrible. My car is shit, my car is junk. The shit, with the definite article the, positive, even superlative. This is a slang expression meaning something is excellent, the best, top quality. Paradoxically, adding the article completely flips the meaning. This restaurant is the shit. This restaurant is amazing. This new album is the shit. That new album is great. So why does this happen? This is a common phenomenon in slang. Adding the definite article turns our ordinary negative noun into a phrase implying the best shit there is, meaning something is so good it's the reference point, the real deal, the best of its kind. So Americans taught me this. Also, Americans taught me what batshit crazy means, but more on that later. The comma operator. This is an uncommonly used way to separate expressions that will run left to right. X equals 10, comma, y equals 20. First assign 10 to x and then assign 20 to y. Seems a bit silly since you could just replace the comma with a semicolon, right? X equals 10, semicolon, y equals 12, semicolon. First assign 20 to x, then 20 to y. But that's a little different. The latter is two separate expressions, while the former is a single expression. With the comma operator, the value of the comma expression is the value of the value of the rightmost expression. X equals 1, 2, 3. Printf x is prints 3 because 3 is rightmost in the comma list, but even that's pretty contrived. One common place the comma operator is used is in for loops to do multiple things in each section of the statement. So for I equals 0, j equals 10, I less than 100, and then we are increasing the value of I and j as a single expression or whatever they call it, right? So the first part here is important, I would say, as one block. Maybe it's not called block, but we will see. Printf d, comma, and another d, and pull that from the I plus incrementing. Yeah. So I'm trying to read this. Printing is printing percentage d and then percentage d. So that would be the first number that is pulled from this variable, and then from the second variable that is also a number, for as long as the I did not reach 100, and the j will of course go over 100 because they are both incrementing at the same time. So in the end it will stop when the I reaches 100 and when the j reaches 110, because it's just where it's going to get stuck at the point when we stop the loop. Conditional operators. For Boolean values, we have a raft of standard operators. A equals b, true if a is equivalent to b. A exclamation mark equals b, which usually means the opposite, right? So this is also true if it's not equivalent to b. Iceblade is correct because it starts with 0. Yes, I agree, but also it will stop on account of the value of I and not j. I meant that part was the important part. I being equal than b, so that's true if a is less than b, if a is greater than b, true if a is less than b or equal to b, and the greater than or equal. Don't mix up assignment with comparison. Use two equals to compare, one to assign. So this is slightly confusing here, and I'm speaking for myself, because two equals are comparison while one of them is assignment. Also, if we flip the value, we still have two characters here, all good. But then we only have one character for comparison of the less than and greater than. So I suppose this makes sense to be only one character, because you cannot use less than for assignment. But either way, it needs to sit. It needs to sit. We can use the comparison expressions with if statements. If a is less than or equal to 10, then print some stuff. Pascal uses colon equals for assignment and single for comparison. I'm gonna say that my Pascal memory from high school faded quite a lot, but now that you have reminded me on this, yes, I remember the semicolon equals in Pascal. But had you not brought this up, I would not remember that, because my high school was fucking shit. That was 30 fucking years ago. Yeah, guys, but it's just syntax, right? They say true programming heroes can be good at programming and simply learn the syntax of another language and just continue, right? But I don't necessarily think it's that easy. For example, like a really stupid example, right? In the Croatian keyboard, we have Z up here and Y down here, but in English they are swapped. So when you're switching from one keyboard to another, it's horrible, right? Luckily, if you mess up and write if A equals B, compiler will complain if you enable all the warnings as author suggested. Yeah. When you know the basics, then it's just a memory game. It is just a memory game. I mean muscle memory, but what I'm saying is if you are writing both in Golang and in C in your life, it's quite possible that you're using both of these languages in your life. Pascal, maybe not so much anymore, but go and see if things are different. Then you could you could forget. That's what I'm. Are you tired? We could stop here. I am a little bit. I was watching the time, but let me just see. Let me just see how much more we have here. And then we have flow control. Okay, let's leave flow control for next time. But let's finish the size of operator. I feel like size of operator could round up the lesson today fine. Like it's not too much. Where did I stop here? Boolean operators. Did we go through Boolean operators at all? Oh, we didn't do Boolean operators. In that case, I think I'll rather stop then. I thought it was just one. I think it's like 3 hours and okay, with some of the side quests. But as we already agreed, even before we started the first book, we did agree that not necessarily we will finish every single lesson on every single stream, because if it reaches like the critical mass that is 3 hours, and this is programming, it is a little bit not difficult from Linux and Bash, but I was going to say it's a little bit more involving, so it kind of drains a slightly more energy. Booleans are quite easy, but you decide. I think I want to stop, not because Booleans are easy or not easy, but because I want to give more of my energy into that. I think I lost it, and I'm afraid that I'm going to skip something that could be important. Yeah. From all of you guys who are on the stream right now, we have a forum. I'm talking to guys and possibly girls who are on the stream or watching video on demand but don't know about the forum, because here we have LPIC lessons here with some homework currently on pause, but also we have like an attachment from this very live stream video lesson that is supposed to be a little bit of a homework, which I didn't write for this lesson. I'm gonna do that tomorrow and reorganize things a little bit. So if you feel like participating, make a account on the forum, get into the sub forum called C Programming, and we'll go from there. And feel free to ask any questions whatsoever about the lesson so far. And let's see where that takes us. And remember to edit into this description. Yeah, Golga Katani, good night. I didn't type anything in the description because I wasn't quite entirely prepared for the new book. And now that I have a good feeling on this book, now I know how I want to phrase the description in the forum, the description on YouTube video, and the video from today will be unpublished as a video on demand until I edit the description. When I edit the description, then I will publish it. It will just be hidden until tomorrow something, right? XGUI4 says C is better than Rust. I mean, even if you're not joking, but I understand that your approach, as many other people, is 50% joke and 50% serious, right? So if we focus on the serious part, there is a lot of value in C being backwards compatible and simply being the core part of both Unix and Linux basically since day one, right? So if you are attaching anything onto any Unix-like system, most likely you will feel at home with doing stuff in C. There isn't any unknowns here. You know what I mean? With Rust being a huge moving target, and it will continue being a huge moving target. Let me try to explain from OpenBSD perspective because they are specific in a way. There, I was reading some mailing list on OpenBSD, and this guy wanted to put some packages into OpenBSD repository, right? But this software was dependent on, was it OpenBSD or I'm not sure. No, sorry, I mixed it up. In OpenBSD, there was a similar discussion where they didn't really want to put Rust and all of the components, so you couldn't quite put the software in there. But what I actually remembered was Debian. So Debian has Rust, but when someone wanted to backport something that is already in Debian Trixie, it's a Rust-based program, and they wanted to backport it, there was a discussion on whether they would backport all of the Rust, all of the new version of Rust that needs to go along with the new version of this program that is supposed to be backported, right? Because you have lower version of Rust in Debian, so you can't quite compile the newer version of that Rust-based program as a backport. Or maybe you can, but it's not verified to work against that version of Rust. It becomes a little bit more complex. This sounds like NeoVim v3-sitter. I don't remember which was it, but if we Google it just a little bit, we're going to stumble upon that. Because I remember the conversation of people asking whether or not they will backport all of the Rust dependencies along with it. So I suspect that in some cases you will be able to backport a newer version of Rust-based program and do it against the older version of Rust, but not necessarily every time this will work. These are some of these nuances with the language being... Good night, everyone. Yeah, good night, Rootlex. Also, the crates. The crates in Rust is something that I am personally afraid of. I understand the benefit of community written black boxes that you can simply import, but most of the times these crates in Rust are coming from the centralized repository, where people put stuff which feels a lot like Arch user repository, right? So as much as you can stumble upon a mine in Arch Linux Arch user repository, at the same way you can stumble upon a mine in the Rust crate that comes from a main Rust repository. I have been discussing this topic with one of my programmer friends who said to me that they have begun programming something in Rust in their company internally, and they use crates. And I asked them how come they are using crates, because I know what his company is producing, and what they are producing is very sensitive stuff, you know. And he told me, yeah, we are using crates, but crates are distributed in-house, and every crate is in-house created. So the software that is being made in their company is big enough that they can afford to the time needed to the investment into their own crates. So they have these black boxes that are not really black because they are making them, but they are making them for themselves. So they are investing in crates now or today, so tomorrow or in the future they would save a lot of time by reusing these components. Okay. This feels like proper way of using crates to me. But when you are like an indie programmer, most likely you will find Rust programmers just pulling crates from the main repository and not entirely verifying what they are doing. So that's that's on you. It's not a flow in Rust language. It's more like a flow in the I know what I want to say, but I need a word. How do you say in English, like a community behavior, how things are being done? I need a word. Like our community here. What is the standard of behavior in our community? What we do? I don't know what the word is. The same for Python, and then yeah. I know. But me personally, culture. Iceblade, thank you. Culture. So, in Rust culture, it is pretty common that single person programmers or indie developers and stuff like that, so not big companies, they will just pull. It's a culture of using Rust. So Rust, right? So you want to program something for matrix, you just pull the Rust crate that deals with all of the black boxy communication stuff with matrix. So eventually there will be a shitload of very popular Rust crates. So at one side, you will have Rust developers really easily making a Rust-based like matrix chat application. Like what is that one in GNOME that Rootlex is using? Fractal. So Fractal is written in Rust, but it's not entirely written in Rust. Only the UI is written in Rust, but in background it is using a crate that gives it all of the pre-written, pre-programmed communication with the matrix server. So when you say this person has made a really good Rust-based matrix chat application, it's not that it's not like they've written it from scratch. They only written UI, but they have pulled half of the code from someone's crate. And this is fine. This is a good rapid development approach. But at the same time, this very same Fractal developer cannot make a matrix. What is the name? Not rooms, but spaces. This developer cannot make spaces in Rust because the crate that they are using doesn't support spaces yet. So they cannot implement spaces because they are relying on someone else's code that doesn't support spaces. If you make your own matrix chat program from scratch in C, you absolutely will be able to create spaces, but you will sweat a lot of blood before you get there. It just requires a lot more investment. So in many ways, people who use C are not that involved in higher level stuff. You know, it's usually lower level stuff that is being created with C. What is the GUI framework? ICED for what? GUI framework for what? Well, while XGUI4 is answering, one last thing I wanted to say is the choice of the programming language, for me at least, it comes mostly from what I want to learn. Okay, so you have like web developers that are people who are really into front-end web development, and they want to be able to design pretty web pages, and they want to hands-on with all of that. So of course they will deal with HTML and JavaScript and stuff like that. That's perfectly fine. On the other hand, like, I don't know, if you are making some multi-operating system program, maybe you will use Java, because Java runs on every operating system precisely the same, because it's not actually running on any operating system. Java is running on a Java virtual machine, which you first need. What is the GUI framework for matrix application? The one I'm talking about, Fractal, that is GTK. Client written in Rust, GTK. Yeah, Fractal is GTK. Yeah. Yeah, looks like this. So it uses all of the standard GNOME design language. That's what I'm trying to say. Design language from GNOME, of course, GTK4 as well. Advaita looks and feels, but in the background, it uses Rust-based matrix. Let me see if I can find it quickly. GitHub. What is the name of the company that makes matrix? Remind me the name of the company that makes matrix. Rust SDK element. Yes, element. Okay. Okay, so I will paste this in chat so you can read it if you want. So here is from the element company. Yeah. The matrix Rust SDK is a collection of libraries that makes it easier to build matrix clients in Rust. A development of the SDK is proudly sponsored and maintained by Element, the company. Element uses the SDK in their next generation mobile apps, Element X, on phones, and has plans to introduce it to the web and desktop apps as well. So web and desktop apps of Element will become Rust-based sometime in the future. The mobile ones already are Rust-based. The SDK takes care of the low-level details like matrix encryption, matrix sync, matrix room state, so you can focus on your app's logic and user interface. See, so the entire SDK that they are giving you that is written in Rust is basically the lower half of your Rust-based matrix application. You only need to take it, leave the development of this lower level stuff to the Element company, and just focus on making your application pretty looking native on whatever you are making it, right? Whether it's GNOME, KDE, Windows, Mac, whatever. Native is native in your own environment. But you must use Rust programming language if you want to use this SDK. If you want to write a C++ based matrix application like Neko, like NeoChat and stuff like that, then you need to use a different matrix SDK or write your own SDK, but that's quite a lot of work. It's not impossible, but it is a question of whether you want your application. Let me put it like this. When Fractal crashes, and it does crash, when Fractal crashes, it's never quite clear whether it crashed because the author of Fractal has made some bad code, or there is a bug in the SDK that they are using and Fractal developer has nothing to do with it, but actually it's the Element company that produces that part of Fractal. I don't know if this makes sense, but this is typical SDK, right? But one of the potential problems for C developers is that there isn't all that much SDK written for in C, right? So Element has decided to go all into Rust, and while they do have some C++ code, for me it feels like they are slowly obsoleting it, and in the future all of the matrix clients will be either Rust based because they will want the supported SDK, or if they're not Rust based, then these are the based developers who are writing everything by themselves, even the cryptography of matrix, the state of the rooms, and all that low level stuff, right? And since I personally am not that interested in Rust language, not that I hate it or anything, I just don't want to do it, right? And if I would want to make a C-based matrix client, that would mean that I need to work a lot harder than Fractal author in order to reach the same level of completeness of the program, Another thing why I have it's an extra language for little benefit. It depends on where you see yourself, right? I am a future hobby programmer. I think that's a fairly good description of me, because it's very unlikely that I will earn money for a living by programming, because first of all, I'm 45, so I'm not sure how much I can learn programming that I can compete with younger people. That's one thing. Another thing, I already have a career in something completely different that barely touches on programming. I have programming a little bit. I have some scripting on Linux, Bash, but actual programming, not so much. And what little I have, I can just use Claude and just skip, yeah, I don't really need to learn programming deeply enough, but there is this desire in me that I want to learn programming for my own pleasure, and the way I want to learn it is exactly how the introduction in this book has described it. I want to understand as deeply as possible how my computer works, and I want to trip over the problems that C as a programming language will give me the freedom about. So what I'm saying, C gives me freedom to trip over stuff and fall down on my nose. But at the same time, it gives me the complete control over the computer. I am not sure if Rust has that much of control over the computer. hobbyist programmer makes sense when you find a small problem that a little bit of code could fix, so it remains fun. Yeah. I want to do little small code that makes it fun for me to learn, make stuff, and I also would like to go even lower than C, which would be assembly. But when I say assembly, I don't mean my PC, because assembly for x86 CPU is let's not get into that. It's too big. Where I would like to attempt assembly is Motorola 68000, which is basically Amiga. That CPU is fairly simple for me to be able to grasp most of the functions of that CPU from the assembly perspective. And another place where I would like to learn assembly is Raspberry Pi Pico 2. Pico 2. Blah blah blah. So this computer is 150 Pico 2, not sure what it is. It's a microcontroller. It's a dual core ARM at 150 megahertz, or dual hazard 3 RISC-V processor, also at 150 megahertz. It's like two different architectures inside one chip, and you can wake up either one of these two. Similar to Micro 33, I don't know what that is. I don't know what that is. It's a microcontroller, okay? It doesn't run Linux. It doesn't run any operating system. You have to program it directly. So it has no kernel, it has no drivers, it has no init system, it has no systemd, it has nothing. It's literally just a CPU, and you have to code it directly. You have to teach it to do things. If you don't teach it, it literally doesn't do anything. It's like having Intel CPU in your hands and not putting it on the motherboard and not installing any operating system, but in a much smaller scale. So I'm going to try to give you an example. For example, you want to make a robot. I'm just giving you a random example. You're making a robot with arms and legs and eyes so that it can see, and it has sensors and motors so it can move the ligaments, you know, and it has these sensors so it doesn't crash into the wall. You can put a computer, any computer, inside that robot. So any computer could be a Raspberry Pi 5. Okay, so here I have Raspberry Pi 5 with SSD, with 8 gigabytes of RAM, with Linux and everything. I can put that into the robot. I need to boot Linux from this computer. I don't have to. I can boot Windows from the Raspberry Pi as well, but usually you will boot Linux. And in Linux, you will do a lot of software programming. You have kernel, systemd, and all that good stuff. But usually, you will do you will program software that runs on Linux, which controls these pins here, right? So from these pins, you can control motors on your robot. You can control sensors on your robot. You can detect when sensors change values. For example, if you have a radar sensor on the chests of the robot, if the value changes, that means that the obstacle is nearby. So when obstacle is detected by this sensor, then your program will make a new decision. It will start turning these motors and turning the robot around. You can do that. You can do all that with Raspberry Pi with Linux. But then you have Raspberry Pi Pico, and let me show it to you. Okay. So a Raspberry Pi normal, and the one in my other hand is Pico. Okay, so I'm going to try to give you a couple of reasons why you would want to use Pico instead of the full-size Linux-powered Raspberry Pi. Is because, first of all, a Raspberry Pi needs storage and it needs operating system installed. It needs to boot. It doesn't function before it boots up completely. If the battery depletes in your robot or whatever, you could get a corrupted file system on your Linux. That's not a very good idea to unplug the power supply of your whatever Linux. There are many reasons why this is not desirable. You can use Pico and program it directly to control your robot. It doesn't boot. It works as soon as you plug it into the power. It already works. It's ready. Robot is working. So there is no boot up procedure. It simply does this one thing that you have teach this this CPU to do, and it literally doesn't do anything else. It doesn't have any storage. It doesn't have any other processes that can possibly crash. Also, it is much faster than Linux in terms of response time. So if you're working with something that requires very, very fast response time, for example, if you're making a helicopter, I'm just inventing stuff. You're making a helicopter and you're flying it with your remote control, and your helicopter is running on normal Raspberry Pi. It could happen that when you pull the joystick, your helicopter doesn't respond as fast as it could with Raspberry Pi Pico, because Pico literally doesn't have any overhead in processing through the operating system. So in some cases, it could be very beneficial for you to shave a couple of milliseconds of response time that this kind of embedded system will give you. Also, Raspberry Pi tends to cost like 100 euros. Okay, there are cheaper ones, but the new ones are quite expensive. While Pico costs 5 euros. Another thing, I want to learn how to program RISC-V processors. I think these are the future. And I want to understand them as much as I can. So that's why I want to first learn C programming for RISC-V, and then I want to learn assembly for RISC-V. So I'm not claiming that I will get very far with this, but sure as fuck, I'm going to try to that. I'm going to attempt, right? You have very little memory here and stuff like that, but none of that matters because it doesn't run an operating system. It just does one thing. By the way, this here is something that I started doing a couple of days ago. It's my new project. Basically, it's going to be a shopping board. I don't think you have been on my Matrix channel when we were discussing that. Maybe you was. Basically, it's my shopping board, and when you pick up the last milk from the fridge, you will just press a button on the shopping board. Just one button, nothing else. You press one button, not that active. Yeah, fine. I'm explaining anyway. So this is my shopping board. You drink the last milk and you press the milk button on my board, and the LED lights up. When LED lights up, it means that you told the system that you have depleted all the milk and the new milk should be purchased by whichever family member. Okay, whichever first family member going to the store. But what I also did is that this shopping board here, this Raspberry Pi Pico, it also transmits via Wi-Fi to my server that milk has been requested, and also it updates the web page with the shopping list. So if the family member is in the shopping right now, shopping for new groceries, and this family member didn't know that milk is missing, but I am at home at the moment when my family member is in the shopping, and I just drank the last part of the milk and I pressed the button on my shopping board. At the very same moment, on the shopping list on the phone of that other member of the family who is in the shop right now, the change happens because it synchronizes through the server. So this is a server-based online shopping board, and it already works. I am actually finished with both design of the hardware, and I'm already finished with the software. Everything works. All I now need is the physical design of the of what the buttons look like. How will I put the labels on the board? How big the board will be, and stuff like that. But it's finished. And sounds like you could get a full video out of that. Yeah, but I want to finish it entirely first because I want, although just the programming part is already finished and I can demonstrate it to whoever, I also want to finish the project entirely first before I publish the code, because I want other people who will want to use my product. I want them to have a complete user experience from the first moment. I don't want other people to be involved into making my product. I'm going to put a free license on it, but I don't want any contributions. I want to put out a completely finished product together with the hardware. Sleep. I think we're good to go. My heart started skipping a lot, so that's a little bit annoying. It stops doing that when I stop talking. Thank you for being here, and good night.